Now let's bring it full circle. Let's talk about the general adaptation syndrome again. So we did establish with sympathetic activity, we have the hypothalamus activating sympathetic nerve fibers. This, and in terms of the endocrine system and how it relates to the fight or flight system, then is one example of these preganglionic fibers. They lead to many tissues, but for the adrenal gland, it's going to go to this part we call the adrenal medulla, and sometimes people call it the medulla, tomato, just know how it's spelled. But what happens is that in response to these nerves activating the adrenal medulla, it's going to secrete epinephrine and norepinephrine. Or again, in like the UK or Australia, they like to say adrenaline and noradrenaline. Same chemical, just different names depending on region. Now, the interesting thing, are epinephrine and norepinephrine the only hormones or secreted in response to the acute phase of the general adaptation syndrome? So there are two of the hormones, but there's another important hormone and another way of getting that hormone. So we still have the amygdala, we still have the hypothalamus controlling all this, but the hypothalamus is going to secrete CRH, or corticotropin releasing hormone. And remember that releasing hormones, they target the pituitary glands. So the pituitary glands are going to that have the receptor for CRH are going to secrete ACTH, or adrenocorticotropic hormone. Now, where does this ACTH go? This goes to the adrenal glands, more specifically this region we call the adrenal cortex. The adrenal cortex, when it binds ACTH, is going to produce cortisol. So this is totally different from epinephrine, norepinephrine. So cortisol, epinephrine, and norepinephrine, they are all hormones released by the acute phase of the general adaptation syndrome. So they're all triggered by stress. When you have a stressor, it's going to trigger the release of epi, norepi, and cortisol. So what is adrenocorticotropic hormone? Again, this is the first step is that releasing hormone, that CRH from the hypothalamus to pituitary. And then ACTH, this is going from pituitary to the adrenal glands. And then the adrenal glands are going to secrete cortisol. And the cortisol is part of a group of steroid hormones we call glucocorticoids. Now what we have here, so this is a cross section of the adrenal medulla, and what we have here is like anatomical directions. So superficial, if someone's only superficial in terms of like how they the people they date, they're only like concerned with appearances, right? They're superficial, they're only skin deep. Whereas deep, that means they're looking for something more below the surface, right? So superficial and deep, opposite directions. So surrounding the adrenal glands, you have something called a capsule. It has this dense connective tissue. And then you have the cortex, and then you have the medulla. Now, cortex and medulla is they are terms you'll see used multiple times throughout this semester. In general, if you have a cortex and medulla, the medulla is the inner part, and the cortex is the outer part. So the cortex is always typically outer to a medulla. So cortex on the outside, medulla on the inside. So with the ACTH, it binds to receptors in the cortex. So this is kind of like middle layer, not quite all the way into the medulla, but if you have all these cells that have receptors to ACTH, ACTH is going to trigger the production and release of cortisol into the bloodstream. Now, in the more innermost part of the adrenal glands is the medulla. And then sympathetic activity. So the interesting thing, instead of having ACTH, you have those preganglionic nerve fibers running from the spinal cord directly to the center or the middle of the adrenal glands, this adrenal medulla, and it's going to trigger them to these cells, what we call chromaffin cells, to secrete epinephrine and norepinephrine. So again, different region, different hormones being released, but they're both being released by that acute stress felt during the general adaptation syndrome. So again, this is why. So what we have here: hypothalamus, the pituitary gland, and the adrenal gland. And this is what we call an axis. So this is how these are. When we talk about a hormonal axis, it's a kind of pathway of, okay, how do things start and where do they end? And how do you activate these in sequence? So this is what this axis refers to. or sometimes it's called abbreviated the HPA axis. So the hypothalamus secretes corticotropin releasing hormone. Then the pituitary gland releases adrenocorticotropic hormone, and that targets the adrenal gland. So if you like mnemonics, I have another one for this one. So I think of it this way. Say you're at, say, in-person sports happen again, and then you have the UH cheerleaders, and they're amping up the crowd up. So you're getting everyone really amped up and getting excited. So I like to think of this. Hawaii cheerleaders practice or perform amazing acrobatics. So yeah, this tells you all of these in sequence. I like mnemonics that have sequences versus mnemonics that are kind of random. Yeah. Oh, so let's put this in. So again, we're a little over time, but if you want to do a few more questions, I still have a bit in reserve. All right, so top hat questions. Next question. Right, put these organs in. So this is interesting. Compared to a regular multiple choice, now you have to drag these in the right order. So which comes first in terms of releasing hormones? A, B, C. Put them in the right order. All right, let's see what people said. So the funny thing is that that's already in the correct order. So yes, this is the most popular order, and this is the correct order. So it is hypothalamus, pituitary, thyroid. Next one. So remember, it's always or actually, let's test it again. All right, so now instead of the thyroid, we have gonads. So put these in order. So female gonads are the ovaries, male gonads are the testes. So in terms of the simple activation of this axis, so all these organs work together in terms of producing the sex hormones, but what's the order? Which comes first? All right, let's see the most. So this is the most popular order, and somebody did put gonads first, so this is another mnemonic. Remember, do you want to think, when it comes to relationships, do you want to think with your gonads first, or do you want to think with your brain first? Brain over gonads, right? So again, brain over gonads, so just think hypothalamus, pituitary, gonads. So HPG axis, that is the correct order. So hypothalamus, pituitary, gonads. Don't think with the gonads first, think with the brain first. And then last but not least, so in terms of order of activation and which organs come first in terms of releasing hormones, right? Most popular order is this, and the most popular order is correct. So again, in all of these hormones that involve the hypothalamus and pituitary, always hypothalamus, pituitary, and then the final target organ. So they all start with HP and then end up with, again, in terms of thyroid, it's HPT. In terms of the ovaries or testes, it's HPG, hypothalamus, pituitary, gonad. And this is the same one we just went over. I was hoping to see 100%, but again, this is time to learn. So HPA axis, and I guarantee if there is an endocrine question on your qualifying exams or whatnot, this is a classic question that's it's like a scientific canon. This is often frequently a question or a topic that often appears in things like the MCAT or NCLEX as well. The HPA axis you definitely should know, because why? It involves things like stress, it involves the endocrine system, it involves the sympathetic nervous system. So this is something you definitely should commit to memory. You should know all of the axes, but you definitely should know the HPA axis. All right, so that's all I have for today. And those of you who are interested in study abroad, you can just go to the UH Manoa Study Abroad website. And so again, office hours, instead of office hours, I'll be in there instead. All right. So Friday, we'll be covering the pituitary gland. Well, we covered most of the pituitary gland, but now I'm going to talk more about, a little more detail about some of these hormones as well. All right. So see you all on Friday, and again, stay healthy until then, and take care, all right?